Alright. Lesson 2, Minerals and Rocks, or Chapter 2, Minerals and Rocks, Lesson 4, Sedimentary Rocks. Last time we talked about rocks, we talked about that we learned that there are 3 different types of rocks: igneous, sedimentary, metamorphic, and we talked a whole bunch more in depth on igneous rocks. Today we're solely looking at sedimentary rocks. After this lesson, we'll be able to describe how sedimentary rocks form, list and describe the 3 major types of sedimentary rocks, and explain how sedimentary rocks are used. My Planet Diary Careers, the cutting edge. If you had to carve tools out of stone, would you know which rocks to use? Dr. Beverly Chiarulli, an archaeologist at Indiana University of Pennsylvania, studies stone tools that were used by people in Pennsylvania 10,000 years ago. Dr. Chiarulli has found that these people crafted spearheads out of the sedimentary rocks called chert and jasper. Chert is hard and has a very fine texture. It is brittle but does not fracture along thin, even planes. So chert can be shaped somewhat easily by flaking off chips, producing the sharp edges needed for spearheads. It says, hey, what properties of chert allow it to be carved into sharp spearheads? Well, we know that it's hard, it has a fine texture, and does not fracture along thin, even planes. How do sedimentary rocks form? The banks of a cool stream may be made up of tiny sand grains, mud, and pebbles. Shells, leaves, and even bones may also be mixed in. All of these particles are examples of sediment. Sediment is small, solid pieces of material that come from rocks or living things. Sedimentary rocks form when sediment is deposited by water and wind, as shown in Figure 1. Most sedimentary rocks are formed through a sequence of processes: weathering, erosion, deposition, compaction, and cementation. And here we have Figure 1, how sedimentary rock forms. Sedimentary rocks form through a series of processes over millions of years. They say, hey, put the terms listed in the word bank in the proper sequence to show how mountains can change into sedimentary rock. Crazy. We'll go and do that at the same time as I read these bubbles for you. So the first step, weathering and erosion. Rock on Earth's surface is constantly broken up by weathering, the effects of freezing and thawing, plant roots, acid, and other forces on rock. After the rock is broken up, the fragments are carried away as a result of erosion, the process by which running water, wind, or ice carry away bits of broken up rock. After that, we go to deposition. The water can carry sediment to a lake or ocean. Here, the material is deposited in layers as it sinks to the bottom. Deposition is the process by which sediment settles out of the water or wind carrying it. Step 3, we get compaction. So the thick layers of sediment build up and gradually over millions of years. The weight of the new layers can squeeze older sediments tightly together. The process that presses sediments together is compaction. And then finally, we've got cementation. While compaction is taking place, some minerals in the rock slowly dissolve in the water. Cementation is the process in which dissolved minerals crystallize and glue particles of sediment together. So boom, we have our mountain. It's a rainy, windy, icy day, and they take some chunks off of the mountain itself, and now they are floating in the wind and being carried downstream by the rain, and they end up landing in a lake or the ocean by which the mountain is near. Then we get, that was weathering and erosion, and then we get the deposition. That's where they settle it, and then they get squished together over many years. And because it gets squished together, it kind of like gets glued together to form the cementation, and then boom, we've got a rock. What are the 3 major types of sedimentary rock? Geologists classify sedimentary rocks according to the type of sediment that make up the rock. The three major groups of sedimentary rocks are clastic rocks, organic rocks, and chemical rocks. Different processes from each of these types of rocks form each of these types of rocks. Most sedimentary rocks are made up of broken pieces of other rock. A clastic rock is a sedimentary rock formed when rock fragments are squeezed together. The fragments can range in size from clay particles that are too small to be seen without a microscope to large, heavy boulders. Clastic rocks are grouped by the size of the rock fragment or particles of which they are made. Some common clastic rocks, shown in Figure 2, are shale, sandstone, conglomerate, and breccia. Shale forms from tiny particles of clay. Water deposits the clay particles in thin, flat layers. Sandstone forms from the sand on beaches, the ocean floor, riverbeds, and sand dunes. Most sand particles consist of quartz. Fun fact. Some clastic sedimentary rocks contain rock fragments that are of different sizes. If the fragments have rounded edges, they form conglomerate. Fragments with sharp edges form breccia. Alright, they want us to match each clastic rock to the photographs that are below them. We have shale. Fossils are often found in shale, which tends to split into flat pieces. Sandstone. Many small holes between sand grains allow sandstone to absorb water. Conglomerate. Rock fragments with rounded edges make up conglomerate. And breccia. Rock fragments with sharp edges form breccia. So give a second, pause this if you need to. Let's see if you can figure out 1, 2, 3, and 4, what goes with each rock. I paused it. If you didn't, pause it now. Alright. So we have shale. Fossils are often found in shale, which tends to split into flat pieces. If we look at 1, 2, 3, and 4, which one looks like it is split into flat pieces? Number 3. Sandstone. Many small holes between sand grains allow sandstone to absorb water. Which one of these looks like it's made of sand? Probably number 4. The sandy hills and dunes. Conglomerate says rock fragments with rounded edges make it up. So we have 1 and 2 left. One of these looks like round edges, and the other one looks like sharp edges, and we know sharp edges is breccia. So therefore, conglomerate is 1. Look at these round boys. And breccia is 2. Look at these sharp boys. Cut your finger on them. You may be familiar with the rocks called coal and limestone, shown in Figure 3. Both are sedimentary rocks, but instead of forming from particles of other rocks, they form from the remains of material that was once living. May they rest now in peace. Organic rock forms when the remains of plants and animals are deposited in layers. The term organic refers to substances that were once part of living things or were made by living things. Coal forms from the remains of swamp plants buried in water. As layer upon layer of plant remains build up, the weight of the layers squeezes the decaying plants together. Over millions of years, they slowly change into coal. And limestone forms in the ocean, where many living things such as coral, clams, and oysters have hard shells or skeletons made up of calcite. When these ocean animals die, their shells pile up on the ocean floor. Over millions of years, compaction and cementation can change the thick sediment into limestone. And then boom, so you can see what it is. On our left side we have coal. We know it starts in the remains of swamp plants that are buried in water. That layer over time gets squeezed together. Millions of years pass. Coal. That's what it looks like. And on the right side we have limestone, which we can see is ocean animals that have hard shells or skeletons that have died. And then they pile up, and then they are compacted and cemented and squeezed together. And then the sediment is slowly changed to limestone. You can even see in this that it's got little fossils all throughout here. I know we haven't applied it, but we have to read the bottom first. Limestone, woohoo, can also form when calcite that is dissolved in lakes, seas, or underground water comes out of a solution and forms crystals. This kind of limestone is considered a chemical rock. Ooh, shaking things up. Chemical rock forms when minerals dissolved in a water solution crystallize. Chemical rocks can also form from mineral deposits that are left when seas or lakes evaporate. For example, rock salt is made of the mineral halite, which forms by evaporation. Like if you have a glass of water and you threw in a boatload of sand, of salt, not sand, and then you set the water outside on a hot day and it all evaporates and you're just left with the salt. There you go, halite. One of our last ones. Apply it! These rock towers in Mono Lake, California are made of tufa. Tufa, a form of limestone. Tufa forms from water solutions that contain dissolved materials. The towers formed underwater. They became exposed when the water level in the lake dropped as a result of water needs for the city of Los Angeles. Read the text about the major types of sedimentary rocks, then answer the questions. Boom! We already did that. We need to know, tufa, is it classic, organic, or chemical sedimentary rock? Well, it was formed from water solutions that contain dissolved materials. And they were formed underwater, and then they were exposed because the water level has changed. That must mean it is a chemical sedimentary rock. Woo, 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 woo. Hey, what do you think? What mineral was dissolved in the waters of Mono Lake and later crystallized to form the rock towers? Ooh, it's an inference, kind of a hard one. What do you think? Well, it says it's made of tufa, a form of limestone, and we know that limestone is calcite dissolved in lakes. So, in order to create these bad boys, calcite had to happen. Okay, but here's a challenge question. Betcha you can't figure this one out. When acid comes into contact with calcite, the acid bubbles. How can geologists use acid to confirm that the rock towers are made of limestone? What do you think? Well, if they need to find out, is this made of limestone? And we know that limestone is made up of calcite, then they just probably put a little bit of acid on there. They just be like, bloop, 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 here's a few drops of acid. Are you gonna bubble? And if it bubbles, they'll be like, calcite, whoop, limestone. Those are probably not the exact words, but you get the picture. Oh, Miss Reams, I have a question. I have a giant question that I need you to answer for me. Yeah, what's up, Miss Reams? Miss Reams, how are sedimentary rocks used though? Like, when am I ever gonna use sedimentary rocks in the real world? Well, Miss Reams, you've come to the right page in the book, page 57. How are sedimentary rocks used? Ooh, well, people have used sedimentary rocks throughout history for many different purposes, including for tools and building materials. Chert, if you remember, was used to make spearheads by people who lived in Pennsylvania more than 10,000 years ago. Other people also made arrowheads out of flint for thousands of years. Flint, not Flint, Michigan, but the rock, is a hard rock, yet it can be shaped to a point. It forms when small particles of silica settle out of water. Sedimentary rocks such as sandstone and limestone have been used as building materials for thousands of years. Both types of stone are soft enough to be cut easily into blocks or slabs. The White House in Washington, D.C. is built out of sandstone. Today, builders use sandstone and limestone on the outside walls of buildings, such as the building shown in Figure 4. Limestone also has industrial uses. For example, it's used in making cement and steel. And then down right here at the bottom, we have a picture of Carnegie Library from Jeffersonville, Indiana. And on the side it says, limestone is a popular building material. However, acid rain reacts with the calcite and limestone, damaging buildings made from it. Oh, bummer. Think about it. Do the benefits of constructing limestone buildings outweigh the damage acid rain causes to these buildings? That's an opinion question if I've ever heard one. Extra credit. It'll be in the section on your assignment labeled extra credit. Here's where you put your answer. Oh wow, Miss Reams, that was so exciting. I love learning about sedimentary rocks, but my favorite kind of rock, you know, Miss Reams, is metamorphic rock. Obviously, that's a lie. My favorite kind of rock is sedimentary, but pretend for the sake of this video. And I really want to learn about metamorphic rocks, Miss Reams. When are we gonna learn about metamorphic rocks, Miss Reams? Hey, Miss Reams, no tears, no time for crying, because Friday, our final lesson for science, is all about metamorphic rocks. Wowza! Definitely need to go catch some Z's, because you can tell. So hey, have an awesome Wednesday. Do some of this work. Check out the math stuff. Percy Jackson final chapter is uploaded. What? You just watched a 16.5-minute science lesson? What? Have a blast with your Wednesday. We've only got 2 more days left of school, and I will see you tomorrow for our final social studies lesson. So crazy. Have fun. Goodbye. Ended off on a high note there. It's fine.